Exercise 310, question 22, I think. Inequalities with x in the denominator. Continued, part 2. So when the inequality is in the denominator, we can't solve normally because we don't know whether this n is positive or negative or whether the inequality sign flips around. So how do we get around that? We multiply both sides by n squared. And then the idea of this is to so that we lose the denominator. So what's the numerator now going to be? So an n cancels from the numerator and denominator, and you've got n bracket n squared plus 8. And I'm going to take, so I've cancelled out the n, then I'm going to bring the minus 6n squared over, greater than or equal to 0. Now what we do not do is we do not expand it. Because if you expand it, you're going to end up with a cubic, and you don't know how to factorize out a cubic. Haven't learned how to do that. Takes a long time. So what we do not do is we do not expand. Do not expand. Just factorize out common factors now. So what have you got? We've got definitely an n is common to both, and then we've got n squared plus 8. What do I write? Minus 6n is greater than or equal to 0. So now I factorize what's in the bracket. Yeah, two numbers that multiply to give positive 8 but add up to give negative 6. It must be n minus 4, n minus 2 is greater than or equal to 0. Now we need to sketch this because this is n squared minus 6n plus 8. Okay? So this is a cubic, and it's a positive cubic because if I started to multiply, look, if I look at the line before here, what's n times n squared? N cubed plus 8n minus 6n squared. Because this is a positive, it is a positive cubic. Because I've got plus n cubed as my leading term. I can tell that by just multiplying the three n's together. Or I can tell that from this row, n times n squared is n cubed. Plus 8n minus 6n squared. A cubic, it doesn't matter what the x squared term is or the constant term or the n term. You need to know what is in front of the cubed term. And it's positive. Now, positive cubic looks like this shape. Now, but in case you forget what it looks like, we can test what it looks like. So, remember, I want to put this equal to 0 and plot the points on the number line. So if I put that equal to 0, what do I get? What are my roots? Like, what are my solutions? 0. No. Two numbers that add up, multiply to give negative 8. Because it should be n squared minus 6n plus 8. It's...
Yeah, but it's like multiply 4 times.
So if you do put this equal to 0, so if I solve equals 0, what do I get? Don't I get n is 0, 4, and 2? So I've got 2, 0, and 4. So first I have to solve the equal 0 one, and then I'm going to see where does this graph lie above the x-axis, right? Where does it lie above? Now, let's say you did not know how to draw it, like this. You can't just take my word. If you don't know how to draw it, it's either going to be this shape or the reverse shape. So what you do, I don't know if it starts down here or if it starts up there. Okay, but I know my curve has to cut through 0, 2, and 4. It has to. You know how if it was a parabola, it would go like that if there were just two of them, or down like that. My cubic goes 1, 2, 3, or it goes 1, 2, 3. All right? Let's say I don't know which way it goes. What I do, I just test, say, -2 over, or -1. Try -1 and put it into this expression here. Or this one, doesn't matter. Try -1. So -1 times, what would this be if that was -1 substituted? -5? So -1 times -5 times -3. And negative times a negative times a negative. Do you get what I just did? This is what I'm going to do here. I'm going to go try n is -1. Let's have a look. Wouldn't that be -1 times, this would be -5 times, this would be -3. I don't have to work it out. A negative times a negative times a negative is a negative. Doesn't matter exactly what it is, but in other words, it's down here. It's not up there. If I got a positive answer, I'd start my curve up here. Negative, you start below the line. No? For example, when n is -1, my value is -15 all the way down here. So this one does go like that, and like that. Let me try another point. So if I try n is 5, so it doesn't bounce off, it cuts. That's the only way you can get through the 3 points. If I try n is 5, should I get a positive or a negative answer? Positive. Let's look. 5 is positive. What's 5 minus 4? Positive. You don't even have to actually work it out. Positive times 5 minus 4 is positive times 5 minus 2 is positive. You actually don't have to work out what the values are. You just have to know when n is 5, that would be positive, that would be positive, that would be positive. A positive times a positive times a positive means my graph is up here. That makes sense. If I tried n is 1, I should get a positive. Let me try. Positive, what's 1 minus 4? -3. 1 minus 2, negative. Positive times a negative is a positive. If I try n is 3, I should get a negative. Positive 3. So 3 times, what's 3 minus 4? That's negative. 3 minus 2 is positive. Positive times positive is a negative. But you don't have to do all of them. You just do one to know where to start. You just know that if it's a cubic, the shape is a squiggle. As long as you know where to start, so you put your 3 points, you test on the left-hand side of the first point. If it's positive, you start up there and go like that. If it's negative, you go like that. All right, we're going to do them all day today. We're going to do more than one. So now that I've drawn it, let me solve. I'm solving this where the star is. Where is this curve? Because I've just sketched it above the line. And before I start, and I always do this and I forget to do it, when you look at the question, what can n not equal? You must write n can't equal 0. We come down to our solution, right? And I'd circle it too. You come down to your solution, and am I looking for above the line or below the line? For my solution, I'm trying to solve this. So I'm here and I'm here. Do you get it? Do I include the point 0? Now this is a greater than or equal to 1, so I need equal to's in my inequalities, but am I allowed to put an equal to with the 0? So yes, I know that n lies between 0 and 2, but it can't equal 0. So I put the 0 is greater than n, but less than or equal to 2. And what is my other value? So I've done this. And greater than or equal to 4. Or equal to. Because it is allowed to be 4. Now, if this was just a greater than, there would be no or equal to's in any of the answer. Look, I would normally just write all equal to's, but I have to check the beginning question. What value of n can it not be? And there always will be a value because you're always doing inequality with x or n in the denominator. So there is going to be a value of n that is not allowed. All right? So with the equal to signs, there's always going to be one that's not equal in one of the bits of the answer. All right, get that down and we're going to do another question. Sorry, that's n. I meant n. Okay, let's look at the next one. All right, before we start, what can x not equal to? Well, I know that 3x minus 2 can't equal 0, so x cannot equal 2/3. So let's make sure that's nice and clear. I'd circle it because otherwise you're going to forget to write it in your answer. Now, what's my step? Inequality with x in the denominator. How do I solve this? I multiply both sides of the inequality by the square of the denominator, which is 3x minus 2 squared. So notice, I've just taken my left-hand side, multiplied by the denominator squared, multiplied my right-hand side by the denominator squared. All good? I don't go expanding. The idea of doing this step is to eliminate the denominator. So what's my new numerator on the left-hand side? 2x squared, bracket, 3x minus 2. Because one of those, 3x minus 2, cancels with the one down the bottom. Can I bring that right-hand side over? What will I get? Plus 3x minus 2 all squared is less than or equal to 0. What I do not do is expand. I factorize. Do not expand under any circumstances. Factorize. What's a common factor? Yeah, 3x minus 2 is definitely the common factor. And in my first term, I'm left with 2x squared plus, in the second term, one of the 3x minus 2 is gone. What am I left with? Another 3x minus 2. See, if you don't expand, imagine expanding this and expanding that, grouping it together, ending up with a cubic, and then you've got to factorize it. It would take you 10 minutes. Do not do it. You are not to expand here. You are only to factorize. Oh, it's okay because it's plus that. Do you know what I mean? Otherwise, I would put the bracket if it was minus that. So now keep factorizing. 3x minus 2. This is 2x and x. And one of them's a positive one. I think it's that. I'm going to check. 2x squared plus 4x minus x minus 2. If you do try and guess it, of course you would check it. Less than or equal to 0. Now, I have to know how to sketch this thing. Do you think that this is a positive? Oh, right. First, let's solve it equal to 0. Put it equal to 0 and what do you get? X is. Bring the 2 over. You'd get 2/3. What else? I'll just let you do it. Bringing the 1 over. It's not negative 2/3 because what you've got is 3x minus 2 equals 0. 3x equals 2. X is 2/3. 2x minus 1 is 0. The 1 comes over. 1 over 2. And the last one is negative 2. Now we need to plot these 3 points on the number line. And I've got negative 2. What comes first? This is really important that you don't mix these up. What comes first, a half or 2/3? We'll do it in a minute. But I'm just putting equals 0 here to know where the points are. So I'm solving this, but I'm not going to write that in my answer. So this is not my solution. I'm trying to solve an inequality. What I'm doing, I'm putting it equal to 0 to know where these points go. But what you might want to do on your number line, you know how x can't equal 2/3? So that you don't write it in your answer, I'd be putting a circle here, an open one, a coloured in one there, and a coloured in one there. Do you know what I mean? Because it's a less than or equal to, open circle on the 2/3, so make sure that you don't, do you understand? That you don't include that in your solution. Now, which way does this cubic go? Let's multiply the x terms together only. So I've got 3x times 2x times x. The only way, see, if I decided to multiply this all out, I'd only ever get x cubed once. I'd get lots of x squareds and lots of x terms, and I would only get one constant term as well. All right? We'll do this more when we do the polynomials topic, but 3x times 2x times x, that's 6x cubed. It is a positive cubic. Now, it doesn't matter if you don't know that yet. We are going to do this in the polynomials topic. We're going to learn how to sketch these, a whole lesson on it, right? So we think it goes this way, but you know what? Let's not think. Let's make sure. Let's make sure that it goes that way. Which point could you test in this? Let's just try x is -3 and we should get an answer. Now, look, you don't have to work it out. What would the first bracket be? That would be -9 minus 2. It's negative, isn't it? Times. If x was -3, I'd have -6 minus 1. That's negative. You don't have to work it out. We haven't got time to work it out. And this one, -3 plus 2 is a negative. 3 negatives. Negative times negative times negative is a negative. Yes, it starts down there. So we've drawn it correctly. The other way is to know that a positive cubic goes that way. I'm going to have to give you a negative cubic one. Now, let's look at the solution. I've put a circle around 2/3 because x can't equal 2/3. I'm looking for, where is this graph, below or above the line? Remember, this is above the line, this is below the line, this equals the line. Where is the graph below the line? What's my solution? Less than or equal to -2, and here. Do I include 2/3? I've got a circle around it. So x is less than or equal to -2. X lies between 1/2 and 2/3. I've missed an equal to sign. Where do I put it? With the half. It would normally be all equals, except go back to the original question and see where you're not allowed to equal at 2/3. All right? Right, another question. Now there, 2x bracket x minus 4 over x minus 1 is less than or equal to 7. So we're going to multiply both sides by x minus 1 squared. And we know that on the left-hand side, one of the x minus 1's cancel out. And we'll bring this 7 bracket x minus 1 squared over to the left. And then we factorize out an x minus 1. And we've got 2x bracket x minus 4 minus 7 bracket x minus 1. Less than or equal to 0. And we've got x minus 1 bracket 2x squared minus 8x minus 7x plus 7 is less than or equal to 0. You know, if you left it like that, you could factorize in pairs if you wanted, but you don't have to. And we've got x minus 1, 2x squared minus 15x plus 7 less than or equal to 0. And hopefully we can factorize that. I'm pretty sure we can. Got to have the 7 there and the 1 there and the minus and the minus. So x minus 1, 2x minus 1, x minus 7. Again, it's a positive cubic. But you can put it equal to 0. Solve this equal to 0 first, and we get x is 1. What else? 1/2 and 7. Plot those three. Make sure they're in order, otherwise you get the answer wrong. 1/2 comes first, then 1, then 7. If you're not sure if it's a positive cubic or not, what do you think? Positive or not? X times 2x times x. Yep. It's a positive cubic because you've got 2x cubed is your leading term. So it is this way, but you can always check. You can just check, let's say when x is 0 is a nice one to check. Try x is 0 just to check that it is a positive cubic. You've got -1 times -1 times -7. Definitely negative. So it definitely starts down there. It doesn't have to be to scale. Okay, go back up to the top. What can x not equal? X minus 1 cannot equal 0. X cannot equal 1. So it can't equal 1. I'm going to put a big circle around it. So I want this graph to be above or below the line. This function has to be less than or equal to 0. That's down there. Greater than 0 is up there. Equals 0 is on the line. So what's my solution? X is less than or equal to 1/2 and 1. X is greater than 1 but less than or equal to 7. Now if this was just less than, there'd be no equal to signs. Do I need to do one of those or not? I should have probably. Okay, this is inequality with x in the denominator. Just looks a bit different. You only need to do one thing to make it like an ordinary question. Look at that, 2 fractions. Look at this, 1 fraction. What do you think you should do? What do you think you should do? Common denominator. Write it as a single fraction with a common denominator. Multiply the first fraction by x and the second one by x minus 1. So we've got x minus 2 bracket x minus 1 over x bracket x minus 1 is greater than 0. So I've write as one single fraction. Right, before we go any further, what can x not equal? X cannot equal 0, x cannot equal 1. Now, I know this is looking a bit weird. Why don't we expand this numerator, make it look a bit better? X minus 2x plus 2, yeah? What's that? X minus 2x plus 2 over x bracket x minus 1 is greater than 0. How else can you make that look a bit nicer? Isn't that just negative x plus 2? Or it's 2 minus x over x bracket x minus 1. We okay with that? That's what that is. X minus 2x is negative x plus 2 is 2 minus x. Better to write the positive term first. Instead of writing negative x plus 2, let's write 2 minus x. So I've got that. What should I now do? Multiply both sides by x squared x minus 1 squared. Do you know what I mean? Or I can put it squared together. Or I can put it in a big bracket, x bracket x minus 1 squared. It's got to be both of them squared. Do you get it? Or I can go like this. How about like that? 0 times x bracket x minus 1 squared. Well, that's just going to be 0 on the right. So what have I got? One of these cancels with one of those, and I've got 2 minus x times what? X bracket x minus 1 is greater than 0. Are we okay with that? Because one of these sets cancels with the denominator. So remember, we're going to solve and put it equal to 0. I'm going to bring that x to the front, by the way. I don't like it there in the middle. I'm going to call it x bracket 2 minus x, x minus 1. And what's your solution to that? Are we good? Are we okay with this step? 0 times that is 0. Right. 2 minus x times one of the x bracket x minus 1's cancels with the denominator. Then I put the x in the front because it looks better. So x is what? Let's go. Come on. Help. What's x? 0. What else? 1 and 2. Or 2 and 1. Make sure you draw them in order on the number line. 0, 1, and 2. Now let's multiply the x terms only. So the leading term, I'm just going to call it the leading term, which is the first term, would be x times negative x times x. I'm multiplying the x's only. I can multiply this whole thing out, but I'm not interested in what all of it is. I just want to know, is this a negative x cubed or a positive x cubed? Multiply the x's. X times negative x times x. That is negative x cubed. This is a negative cubic. So it goes this way. Now, when we do polynomials, are there any values not allowed? 0 and 1. I'm just going to put some circles there, all right? Okay, so negative cubic, but let's say you didn't know which way to draw it. What else could you do? Can't you try x is negative 1? We know we've got 0, 1, and 2. We need to know, do we start up or down? Try x is negative 1. What have you got? Negative 1 times, what's 2 take away negative 1? It's 3. Times negative 1 minus 1 is negative 2. Negative 1 times 3 times negative 2 is positive 6. Yes, we started up. And you just cut once, cut once, cut once. Okay, let's solve our question. This is a greater than 0, 1. Greater than 0. Where is it? Above the line.
Less than 0.
X is less than 0 and x is between 1 and 2. Do I put any equal to's? No, because there's none in the question. So no equal to's. Yes, I know it can't be 0 and 1, but see the question, the reason we've been putting all the equal to's, I'm going to go back. The question has equal to's. Look, the question has equal to's. The question has equal to's. That's the only reason I put them. This question does not have equal to's at all. So I suppose even if you didn't do this, they were all going to be less than. There were never going to be any equal to's. Do we get it? So I should have mixed them up a bit more before. Not sure where I'll stop recording here, but one way to do this question would be take everything over to the left-hand side, less than 0, make a common denominator and solve it the way we just did this question up here, because it's almost identical. The second method would be to deal with the x squared and the x plus 1 squared using normal methods. So if we want to deal with the x on the denominator, we multiply both sides by x squared. And if we want to get rid of the x plus 1 on the denominator, we multiply both sides by x plus 1 squared. So we can do it together. Multiply by x squared, x plus 1 squared. When we do that, we get cancelling of the x's here on the left and cancelling of one of the x plus 1's on the right. We now take everything over to the left-hand side. So x bracket x plus 1 squared minus x squared bracket x plus 1 is less than 0. What do we do now? We factorize out what? X bracket x plus 1. What are we left with? X plus 1, I'm going to put extra brackets, so I'm going to minus x. So I didn't need actually. So I took out an x plus 1. So I've got x bracket x plus 1. What's this? X plus 1 minus x. What's that? What's x plus 1 minus x? 1. This is great. It's 1. So this is just, is this a cubic this time or a quadratic that I'm sketching? It's a parabola. So it's x bracket x plus 1 is less than 0. Remember we solve x bracket x plus 1 equals 0. I'll sketch it. X is 0 and negative 1. Let's sketch. Concave up or down? Concave up, cutting at negative 1 and 0. And where is your graph? What? Above or below the line are we looking for? And where is the graph? Below the line. There's no equal to's in the question. Of course, you're not allowed to have 0 and negative 1 as your solutions. You know, x can't equal 0, x can't equal negative 1. So what's my answer? Negative 1 less than x less than 0. Okay, so sometimes the question that was actually probably easier than the other ones. But when you look at it, you think, I don't know what to do. You've got two options. You can just deal with the x and deal with the x plus 1 by multiplying both sides by x squared and x plus 1 squared. Because you're dealing with that first and then that one. Or you can make a common denominator like we did in the question above it and do something similar to what we did before. Okay?